Hello everyone. This is another important problem for exam purpose. This is a case study question from model paper. And in this problem, it looks a very complex circuit, network of circuit, but it's actually a very simple problem if you know parallel connection. In domestic household, we use usually parallel connection here. The supply is given as 220 volts here. From transmission line is 220 volts here. And the current is, from mains, what is the current here? 22 amperes is coming. The 22 amperes is divided among these 5 rooms here, right? But voltage in each room remains 20 volts. Because of parallel connection, the voltage remains same here. 220 volts, 20 volts, 20 volts, 20 volts. In each room, the voltage remains same here, but currents get divided, right? The current get divided here. The main current is 22 amperes. The main current is 22 amperes here. It gets divided among these rooms. Yes. Now, let us draw this equivalent circuit here. Now, let room 1 has resistance. Let room 1 has resistance R1 here. Let room 2 has resistance R2. Let room 3 has resistance R3. Let room 4 has resistance R4. Let room 5 has resistance R5. Now, how all the connections are connected in a household here, domestic supply, usually parallel. We always connect parallel here, right? That's why each room will get 220 volts. Otherwise, equipment won't work. See here, equipments requires constant voltage supply, that is 220 volts. But current will vary depending upon load here. For example, LED bulbs will draw less current, fan will draw around 0.3 amperes, and your washing machine will draw 2 amperes of current, a geyser will draw around 8 amperes of current. But ultimately, the voltage should remain 220 volts only. The current will be different here because it's a parallel connection, right? That's why we connect parallel in domestic supply, not series here. We won't connect series here because voltage should not get divided here. Voltage should be constant here, right? Therefore, it is parallel here. And in the given problem, they told the space 5 and 4 have same resistance. Let it be R here. Space 5 and 4 has same resistance here. Let it be R here. Let it be R here. Yes. And space 3 has 20 ohm. Space 3 has 20 ohm resistance here. And space 2 has 30 ohms. And space 1 has double that of 5. That is 5 is R here. Therefore, space 1 has 2R. Right. Now, we know already total current here. See here, it's a AC supply. It's a AC supply. See here, it's a AC supply. That's why I drawn this AC symbol here. You learn more about AC symbol in 220 in PUC. Even though it is not necessary for 10th standard, I just drawn to make you understand the concept here. This is a AC symbol and total current is 22 amperes here. Therefore, we can find R equivalent here. We can find R equivalent here. All are in parallel. We can find R equivalent here. That is total voltage upon total current. That is 10 ohms. The equivalent resistance is 10 ohms here. And what is the formula for equivalent resistance here? 1 by R equivalent is equal to 1 by Rn. All are in parallel. 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5, right? 1 by R5 because all are in parallel. Now, I know R here. R1 is 1 by 2R plus R2 is 1 by, R2 is 30 here, 1 by 30. Room 3 is 20 ohms here, 1 by 20. Room 4 is 1 by R. Room 5 is 1 by R. Now, you regroup them. Now, I know R equivalent here, 1 by 10 ohms. 1 by 10 here. 1 by 2R, 1 by R, 1 by R. I will regroup them. 1 by 2R plus 1 by R plus 1 by R here plus 1 by 30 plus 1 by 20, right? Is equal to 1 by 2R plus R, the LCM is 2R here. 2R 1 za, R 2 za, R 2 za. 1 plus 2 plus 2 plus the LCM here is The LCM is 30 and 20, LCM is 60 here. 32s are 23s are 2 plus 3, right? 1 by 10 is equal to 5 by 2 are 1 plus 2 plus 2 is 5 plus 5 by 60, right? Now I'll say 5 ones are 5 12s are, right? Implies 1 by 10 is equal to 5 by 2 r plus 1 by 12. I send this 1 by 12 that side. Implies 1 by 10 minus 1 by 12 is equal to 5 by 2r, right? Now LCM of 10 and 12 is what here? 60. 10 6 are 12 5 are 1 6 are 6, 1 5 are 5 is equal to 5 by 2r. Implies 6 by 5 is 1 by 60 is equal to 5 by 2r. Cross multiplier. Therefore 2r is equal to 60 into 5. R is equal to 60 into 5 upon 2. 2 ones are 2 30s are 35s are 150 ohms. Therefore R is 150 here. What is the net resistance of space phi here? Net resistance is R here. Therefore space phi has resistance of 150 ohms, right? R is equal to 150 ohms. Now what is the current in space 3? What is the current in space 3? Yes, observe your circuit here. Observe circuit here. In space 3 the voltage is 220 volts because it is parallel connection and the resistance of space 3 is 20 ohms. Therefore space 3 has a current of what here? I is equal to, let be I here, V upon R, that is 220 upon 20. 2 ones are 2 11s are. Therefore current is 11 amperes. Now, what should be placed? Current is 11 amperes here. Yes. Now, what should be placed between main connection and rest of the house? What should be placed between main connection and rest of the house here? We should place what here? To save them from accidental high current. To save from accidental high current, we use what here usually? Fuse. Since the total current is 25 ampere, 22 amperes here, we can use a fuse rating of 25 amperes. It is not asked in the problem, you just mention fuse here, that's over. But since the main current is 22 amperes here, we can use a fuse rating of 25 amperes, maybe 50 amperes, etc. Fine. You should use a higher rating of water total current here. Total current is 22 amperes, so you should use around 25 amperes or 50 amperes like that. Yes. Very simple problem. It's a domestic electric circuit. All should be connected in parallel. Just we need to apply equivalent resistance formula here for parallel connection and we get R here. Very simple problem and very interesting problem also. Hope you understood. Any doubt you can contact me in YouTube and write in a chat here. Thank you everyone.